Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to my lecturer Zahari and to all of my fellow classmates. My name is Siti Nurul Laila Nadira binti Muhammad Bakri from class Chair 4 ELE242, and today I'm going to do a presentation video on ELE242. So this is question 1. Figure Q1 shows a subtractor circuit. Assuming the op-amp is ideal, determine the output voltage V0. We can use either calculation method or simulation method. In order to know if the simulation method is correct or wrong, so calculate the value of the V0 by using calculation method. As you can see here, we can find the value for V plus by using voltage divider rule. 1K divide with 1K plus 2K and times with 9 volt. So we will get the value for V plus is equal to 3 volt. The value for V plus is equal to the value for V minus. So the value for V minus is equal to 3 volt. And we substitute the value for 3 volt into the equation, and we will get the value for V0 is equal to negative 4 volt. So, for the calculation method, the value for output voltage is equal to negative 4 volt. So, for the simulation method, I use Fortis 8 professional software to construct the circuit. As you can see here, the component we need is 741 op-amp, 1K resistor and 2K resistor. First, we need to place the op-amp at the center and we need to Y mirror the op-amp. The 1K resistor is connected with the op-amp, and we must place the 1K resistor at the top of the op-amp and at the bottom of the op-amp. These two resistors is connected with the DC generator. So we must take the DC generator and connect with the resistor. The 1K resistor at the bottom is connected with the ground. The op-amp is connected with the DC voltmeter. The DC voltmeter is used to find out the value of the output voltage. The negative terminal of the DC voltmeter is connected with the ground. So, the value of the first DC generator is equal to 10 volt. Meanwhile, the value of the second DC generator is equal to 9 volt. So, to find out the value of the V0, we must run the circuit. So, the value of the output voltage is equal to negative 4 volt, the same as the calculation method. It is proven that the simulation method is the same as the calculation method, and it is correct. So, for the question 2, the figure Q2 shows a combination of two operational amplifiers circuit. Determine the output voltage for V01 and V02. Assume all op-amps are ideal. So this is the circuit for the question 2, and we need to find the value for V01 and V02. This is the calculation method for question 2. First, we need to consider A1 and use the VDR to find the value for V+. The value for V+ is equal to 1.125 volt. The value for V plus is equal to the value for V minus. So the value for V minus is equal to 1.125 volt. And substitute the value into the equation. 5 minus 1.125 over 120k equal to the 1.125 minus V01 over 300k, and we will get the value for V01. It is equal to negative 8.56 volt. And we use the value for V01 into this equation, and we will get the value for VA2 plus is equal to negative 3.27 volt. The next step is we need to consider A2. V plus is equal to V minus, and it is equal to negative 3.27 volt. 0 minus with negative 3.27k over with 27k and equal to the negative 3.27 minus with V02 divided with 56k, and we will obtain the value for V02. The value for V02 is equal to negative 10.05 volt. So the value for V01 is equal to negative 8.56 volt, and the value for V02 is equal to negative 10.05 volt. So for the simulation method for question 2, we need to use op-amp, 300k resistor, 120k resistor, 56k resistor, 30k resistor, 27k resistor, 20k resistor, 18k resistor, and 15k resistor. First, we need to place the op-amp. We will use 2 op-amp, and the op-amp we need to Y mirror both of the op-amp, and we need to place the 20k resistor at the center of the op-amp. The 120k resistor and 30k resistor is connected with the first op-amp. This 2 resistor is connected with the DC generator. So we need to place the DC generator. The first DC generator is equal to 5 volt. And the second DC generator is equal to 3 volts. So we must connect the DC generator to the resistor, and we need to place the 18k resistor at the bottom of the first op-amp and the 300k resistor at the top of the op-amp. The 18k resistor is connected with the ground. So we must place the ground at the below of the resistor, and we must place 15k resistor and this resistor also connected to the ground. Only 2 resistors left to use, so we need to take 56k resistor and 27k resistor. The op-amp is connected with the DC voltmeter. The DC voltmeter is used to find the value of the output voltage, and the negative terminal of the DC voltmeter is connected with the ground. As same as before, so the positive terminal of the DC voltmeter is connected with the op-amp. The 27k resistor is connected with the ground. And after the circuit is done, we can find the value for output voltage by running the simulation. Oh, my mistake. It is not connected with the ground. This 15k resistor is connected with the DC generator. The DC generator value is equal to 0.7 volt. So after that, we can run the circuit to find out the value for the output voltage. So this is the value for the output voltage, negative 8.56 and negative 10 volt, the same as the calculation method. For question 3, the figure Q3 shows an instrumentation amplifier circuit. We need to calculate the output voltage and assume all op-amps are in ideal condition. So this is the circuit for the question 3, and we need to do the calculation method and the simulation method to find the value for V0. This is the calculation method for the question 3. First, we need to consider A1. They are A1 plus equal to the A2 minus, and it is equal to 10 volt. And the second one is A1 plus is equal to A2 minus, and it is equal to 5 volt. This is based on the question given, based on the circuit from the question. So we can find the value for V01 from this equation. V01 minus 10 volt over 1.5k equal to 10 volt minus 5 volt over 1.2k. And the value for V01 is equal to 16.25 volt. The next step is we need to consider A2. A1 plus is equal to A2 minus, and it is equal to 5 volt. And we need to substitute the 5 volt into the equation, and we can find the value for V02. The value for V02 is equal to negative 1.25 volt. Then we need to consider A3. Negative 1.25 minus VA3 plus over 1k equal to VA3 plus minus 0 over 1.5k. Then we will obtain the value for VA3 plus. It is equal to negative 0.75 volt. The value for VA3 plus is equal to the value for VA3 minus. So it is equal to negative 0.75 volt. Substitute this value into the equation, and we will get the value for V0. So the value for the output voltage is equal to negative 17.75 volt. This is the value for the output voltage for question 3. As for question 3, for the simulation method, we will use 741 op-amp, 1k resistor, 1.2k resistor, 1.5k resistor, and 18k resistor. So we will use 3 op-amp. So we must place the op-amp at their condition, at their place, and we must put all of the resistor. First, we will use 1.5k resistor, 1.2k resistor, and 1.5k resistor is at here. Then we will use 18k resistor at the top, and another 18k resistor, and the one is 1k resistor at the bottom, and the last one is 1.5k resistor. So all of the resistor is in vertical condition, so we must change that condition. And the op-amp is connected with the DC generator. So this value for the DC generator is equal to 10 volt. And the other one is equal to 5 volt. So we can connect all of the wires. Not all of the resistor is in vertical condition. Some of them is in horizontal condition. Sorry. To the resistor and another one. And this op-amp is connected to this resistor. Same with the negative terminal, and the op-amp is connected with the DC voltmeter. It's the same as before. The DC voltmeter is used to find the value for output voltage, and the negative terminal of the DC voltmeter is connected to the ground. So after that, we can find the value for output voltage by run the circuit. So the value for the output voltage is equal to negative 17.6. It is the same with the calculation method. So this is the value for the output voltage, negative 17.6. This is the circuit for the question 4. We need to assume that all of the operational amplifiers are in ideal condition, and we need to find the output voltage V01, V02, and V03. As for calculation method for question 4, we need to consider A1, consider A2, and consider A3. For consider A1, the value for V plus is equal to value for V minus, so the value is equal to 0 volt. And we need to substitute the value into the equation, into this equation, and we will get the value for V01 is equal to negative 4.5 volt. So for the consider A2, the value for A plus is equal to the value for A minus, so the value is equal to 2 volt. The value for V02 is equal to 2 volt by using this equation. And as for the consider A3, we need to use the value for A plus is equal to the value for A minus, and it is equal to 0 volt. We need to substitute the value for 0 volt into the equation. Negative 4.5 minus 0 over 1k plus 2 minus 0 over 2.4k equal to 0 minus V03 over 2k, and we will find the value for V03. It is equal to 7.33 volt. So we need to run the simulation method to find out if the value for V01, V02, and V03 is the same with the calculation method. As for question 4, for the simulation method, we will use the component op-amp, 2.4k resistor, 2k resistor, 1.5k resistor, and another 1k resistor. So we will place the 3 op-amp and the 2k resistor is connected with the DC generator. So the value of the first DC generator is equal to 4 volt, and the value for the second DC generator is equal to 2 volt. So the DC generator is connected with the resistor, and we will place the 1.5K resistor at the top of the first op amp, the 2K resistor, and the 1K resistor is connected between these two op amps. So we will need to arrange the components so it will be nicely. The 2.4K resistor is located between the second and the third op amp. And each of the op amp is connected with the DC voltmeter. So the DC voltmeter is used to find out the value of the output voltage. The negative terminal of the DC voltmeter is connected to the ground. After that, we must connect all of the wires. This op amp is connected with the 2K resistor. After we're done with the circuit, we can run the simulation to find out the value of the output voltage. So as you can see here, the value for V01 is equal to negative 4.5. The value for the V02 is equal to 2 volt. And the value for the V03 is equal to 7.33 volt. It is the same as the calculation method. Negative 4.5 for V01, 2 volt for V02, and 7.33 for V03. So the simulation is correct as the calculation method. Thank you.